Alright, so we're going to start looking at lines in more depth, and one of the things we're going to look at is the slope of a line. This is sometimes referred to as rate of change or speed of the line, and it tells you how quickly the y values change with respect to the x values. If you have 2 points on a line, we know that 2 points can define a line, then you can determine what the line of that slope is, and the formula we use is the following. M stands for slope, equals that symbol, that triangle there is a Greek letter delta, which usually means change, so the change in y over the change in x. And the way you calculate the change is you take your second y minus your first y value, and you divide that by your second x value minus your first x value. So, for example, let's say we were asked to find the slope of the line passing through these 2 points. Now, sometimes I've seen students, especially early on when they start using this formula, trying to keep the value straight, they may write above those numbers, this -3 is the first x, 5 is the first y, 2 is the second x, 7 is the second y. If that helps you, please do it. And then we're just going to use our formula here. And again, I usually recommend anytime you run into a formula you're not familiar with, write the formula out every single problem you do it with. I'm not going to do that in this video, but you may want to do that when you're doing your problems. And then plug in the numbers. 7 is y2, 5 is y1, positive 2, or 5 is y2, positive 2 is x2, and then -3 is x1. And be careful about those signs, because you're thinking I'm subtracting and then you see a negative. Don't forget to put the negative sign in there, because 2 minus a -3 is really 2 plus 3. So that's why it's 2/5. Some quick reminders about fractions, some things you're going to run into. If you have 0 divided by a number, that's 0. If, on the other hand, you have a number divided by 0, that's undefined. Or if you have 0 divided by 0, that is also undefined. So make sure you don't get those confused with like 11 divided by 0 being 11. That would have to be 11 divided by 1. Also, if you have a fraction, you should reduce it down to lowest terms. If you get something like this, -3/1, don't leave it that way. Write it as -3. So just kind of keep in mind, when you have something like 9/6, we want to reduce that fraction to 3/2. Now, you could, if you chose, instead of writing 3/2, you could write 1 1/2 if you like that better. Or you could write 1.5 if you like that better. But in any of those cases, you should be writing it in one of these reduced forms, not leaving it as 9/6. Alright, another thing we're going to look at is the relationship between two different lines. And so one of the relationships is if the lines are parallel. And if they're parallel, that means their slopes are equal to each other. The slope of the first one equals the slope of the second one. That should be pretty obvious. Just make sure everything's reduced down to lowest terms to make that determination, but it should be pretty clear. Two lines are perpendicular if their slopes are opposite reciprocals. So symbolically, what that means is if you were to change the sign of the second slope and flip it over, it would be equal to the first slope. So for example, if your first slope is 2/3, in order to be perpendicular, the second slope would have to be a -3/2. Some things about parallel and perpendicular lines that may not be immediately obvious. You should note that all lines with a slope of 0 are parallel to each other. And that should make sense. 0 equals 0, so they should be parallel. But what may not be immediately obvious is that all lines with a slope of undefined are also parallel to each other. So even though undefined isn't a number, we say if it's undefined, it's parallel to another line that's undefined. And all lines with a slope of 0 are perpendicular to all lines whose slope is undefined. So we can kind of think of undefined and 0 as being kind of opposite reciprocal type relationships. And what we're going to see is these are actually horizontal and vertical lines we're talking about here. Alright, so let's say we had a problem like this. Is a line that passes through the points -2, 8, and 6, negative 4, which means those are solution points on the line, parallel, perpendicular, or neither of these to the line that passes through the points 4, 2, and 12, 8. And the way we're going to come to this determination is we're going to realize that from what I just talked about, it's all based on the slopes. So we're going to calculate the slopes of these two lines. So we'll calculate the first slope using negative 2 and 8 and the point 6, negative 4. And we're just going to use our slope equation, negative 4 minus 8, 6 minus negative 2, and then just simplify that. Negative 4 and negative 8 is negative 12. 6 minus negative 2 is the same as 6 plus 2, so 8. Divide top and bottom by 4, and we get negative 3/2. And then we're going to compare that to the second slope. So the second slope, you're going to use 4, 2, and 12, 8, so 8 minus 2 over 12 minus 4. 8 minus 2 is 6, 12 minus 4 is 8. We've reduced that, and we get, divide top and bottom by 2, and we get 3/4. So are these parallel? Well, clearly they're not equal. One's negative, one's positive, so right there we know they're not equal. But also one's 3/2 and one's 3/4, so not equal, not parallel. Are they perpendicular? Well, they are opposite signs, so that's a good sign. One's negative, one's positive. But in order to be perpendicular, they also have to be reciprocal. So the perpendicular slope for negative 3/2 would be positive 2/3, not 3/4. So these are neither. Now, it may come as an idea that, instead of calculating all this, why don't we just graph these lines? And, okay, let's say we did that. And you'll notice I labeled my grid here. Normally I don't label them if I'm just counting by ones, but since here each line is a 2, I put some labels on here. I labeled every second line so you can see that, oh, I'm counting, 2, 4, 6, 8, 10, 12, so on. So you know what scale I'm using in this picture. If you look at the points, are all even numbers, so I thought this might be a good choice. So I'm going to plot these points and draw some lines and see if this, looking at the picture, is evidence enough that I could have done it that way. So negative 2, 8. So I plot that point. 6, negative 4. So I plot that, and I draw the line through those 2 points. So that's the first line. And then I go to the second line. 4, 2, so 4 up 2. And then 12, 8, so over 12, up 8. And I'm going to draw a line through these. Now, if I just had this picture, and that's all I had to go on, I probably would, pretty reasonably think that that looks like they're crossing at a 90-degree angle, which is what a perpendicular lines are. But in actuality, these are crossing at an 86.84 degree angle. Not quite 90. They are not perpendicular. But if you just went by the picture, that distinction would be hard to tell. That's why we need to use the actual calculation of the slopes to determine whether these are parallel, perpendicular, or neither. You can think of a similar situation where two lines are almost parallel and really close, but in actuality they would meet somewhere along the line because their slopes are not exactly equal. So drawing a picture is not evidence for this type of problem. You have to actually calculate the individual slopes.